Hello. Today I want to talk about something a little bit different. I want to talk about BigQuery ML. BigQuery ML is a way to make and train machine learning models entirely in SQL and make predictions based on data that you've imported into BigQuery. So I want to talk a little bit about what you can do with it and how it's different from some of the other machine learning offerings that Google has. So it's different, first of all, in what you have to do with it compared to, let's say, like AutoML, first of all. So it's not a completely automatic offering. So you're going to have to do your own feature selection. You're going to have to do your own train test split, for instance. It's not going to be an entirely end-to-end solution, which can be cool. You know exactly what's happening, for instance. But the trade-off for that is that it's definitely a more cost-effective solution than what you would get with AutoML, and it's certainly possible, depending on the amount of data that you need to process, to keep it well within the free tier. Let's take a look. Obviously, when you're using BigQuery, price is always going to be a consideration. So let's look real quickly at the pricing at the pricing model and what's included in the free tier. So if you're using what's called the queries and what they're calling analysis, so the first terabyte is going to be free for each month, which is the same as what you get normally with non machine learning queries in BigQuery. So the first terabyte is going to be free. That's anything other than actually creating the model. So doing any kind of predictions using the model, any kind of inspection or evaluation of the model, which we'll go through in a little bit. That's all included as kind of analysis. That's all included in that terabyte. And then you get 10 gigabytes of data per month for free creating the model. That's obviously a lot less than a terabyte, but the model files aren't necessarily huge, and that's still pretty generous. You can do an awful lot with that 10 gigabytes per month. So there's an awful lot that you're going to be able to do on the free tier. Definitely, there's definitely a lot you can do. So with that said, why don't we start with a sample project. We can walk through making some predictions. So I have here a sample data set that I've gotten from Kaggle. So if you're not familiar with Kaggle, Kaggle is a fantastic source of all kinds of data sets. They have contests and that sort of thing if that's something that you're interested in. But they have data sets of all kinds of classification, image data sets, and all kinds of other things that are really great for getting started to work with machine learning. So this one is a sample data set for predicting churn for a telecom company. So I downloaded that, I imported it into BigQuery, and we can look at the categories, the features that are in this data set. So what we're going to be predicting is churn, which is all the way down here. You can see it's just a yes/no category. So one thing that I actually like about this data set is that it needs to be cleaned up. There's a lot of things that are less than perfect about this. So obviously there's a little bit of inconsistency in the capitalization in the columns, which isn't a huge deal. You can also see in some of these categories, like here, senior citizen, like this is a Boolean column. This one is 0 and 1. This one for like dependents, for instance, is also a Boolean column, but they've chosen to put yes, no for that one. And some of these, it's a little bit hard to tell initially. So like multiple lines looks like it's going to be a yes, no, but it's actually categorical data. There's some other options. So if we look over here, I've done a little bit of initial analysis on kind of a breakdown of how many values are going to be available here. So churn, this is what we're predicting. This is kind of the class breakdown. And, when you're starting a machine learning project, you kind of want to be cognizant of what the class breakdown is on the actual category that you're predicting. Some of your diagnostics are going to split a little bit differently. If you're going to be predicting something that's a little closer to 50-50, or if like this, it splits a little bit differently. Like it's a little bit more lopsided. So you can see there's a lot of categorical data that we're looking at here. Device protection, multiple lines. Does the customer use online backup, online security, paperless billing, the payment method, whether they've purchased streaming movies, purchased streaming TV, tech support. These total charges and monthly charges. I think you could actually make a case that total charges and monthly charges, while it is a number, it probably could almost be categorical data, because there's only, 2, 4, 6, 8, 10, values. In the real world, a telco company would have lots of different, pricing options. This particular, sample company, I guess doesn't have very many prices, or doesn't have very many products that they offer. So there's only, a small number of tiers, but I think we'll go ahead and leave this as a numerical value. This is one of the actual true numerical columns. This is just tenure. I think this is, months of tenure. And then contract type. And then this is another Boolean column of whether they have phone service. So the next thing that we're going to do is create our train test split. So in other words, we're going to take the entire telco database, which has about 7,000 records in it, and we're going to break it into about an 80-20 split. We're going to take 80% of that data, and we're going to use that to train our model. We're going to take the remaining 20%, and we're going to use that to test the model to see how accurate it is on data that it hasn't seen before. So BigQuery ML doesn't really, that I've seen at least, have a function to do that in ways that other machine learning libraries do. If you done machine learning in Python, like the scikit-learn library, for instance, has like a train test split, functions for it. I have seen there is actually a really great technique that I've seen that I'll link in the description, that I will walk you through right now. So what this does is kind of a neat trick. It's going to use the farm fingerprint function, which is basically just like a hash. So what this is going to do, it's going to take, let's go back to our telco data. So if you see this customer ID column, so what this is going to do is it's going to take that customer ID column, it's going to run it through farm fingerprint. Farm fingerprint is a hash that is going to reduce whatever is inside that column down to an integer. If that integer is divisible by 5, and if the integer is divisible by 5, it's going to take it and it's going to place it into our test our test database. So this is going to be, we're basically taking 2 queries. We're going to run it once where we want all the ones that are divisible by 5, and that's going to go into our test database, and then we're going to run it again where we take all the ones that are not in our test database. And so that's going to wind up being our training database. So you can see we're creating our table. Our main database is called telco. So now I'm making one called telco test, and I'm selecting everything from telco, where mod, which is going to be, we're looking for a remainder. So the absolute value of farm fingerprint of customer ID. So this is where the mod of 5 equals 0. So I'm going to run that. And then this is going to make a new database. Okay, so telco had 7,000, and then telco test at 1423. All right, and then yeah, so just about exactly 20%. All right, so now we want to build a train database that has everything from telco that's not in telco test. And that has 5620. All right. Okay, so now the next thing that we want to do is build out our query, which is essentially our feature selection that we're going to pass to the model. So what I'm going to do, I have a query that has already been started. I'm going to go ahead and just use, if this was a real machine learning project, we do an actual feature selection exercise. We would go ahead and run some functions that would see what features are pulling the most weight and are exerting the most effort on the target variable. For right now, I'm just going to go ahead and use the ones that are pertaining to the service lines for the company. So let's go ahead and look at this. So I'll show you what I have here. So it uses BigQuery ML wants you to call the target variable label. If there's some reason that you can't use label, like if you have a column in your database that's named label, when you're creating the model, you can pass it an attribute that says this is what I actually need to name my label. Otherwise, you can just name it label. And then for the other columns, I'm just going ahead and passing them. I'm using this if null statement. So if it's empty for some reason, I'm passing in the empty string. Otherwise, I'm just letting the actual value flow through. And then it's naturally just one-hot encoding these. So it's a categorical variable. So it's creating behind the scenes. It's creating, if you're familiar with how one-hot encoding works, it's creating, let me go back to the database. So if we look at, for instance, let's look at internet service. Let's use multiple lines. So multiple lines has 3 values. So there's no, yes, or no phone service. So under the hood, BigQuery ML is going to create 3 features. So there's going to be multiple lines no, multiple lines yes, and multiple lines no phone service. So it's doing that for each of the values in all of these other features, and it's just going to do that. It's going to do that automatically. Okay, so at this point, we're ready to do the the actual model creation. So let me go back here. Let's copy this. So there are several different model types that we could pass in. The reason I chose logistic regression here is because churn is the type that we're predicting here. So churn just has 2 options, which is that is what logistic regression is. If churn was a number, then we would be linear regression. Initially, I believe when BigQuery ML launched, it was just the 2 types, logistic or linear regression. There are a whole number of different kinds of models that you can choose from now. There's TensorFlow, I believe, is a type. You can do ARIMA for time series forecasting. There's things that you can do for preferences and all kinds of other different kinds of models that you can choose from. One thing to keep in mind also is that this doesn't have to. The model that you create does not have to stay inside of BigQuery. You can export the model to a Google storage bucket, and then you can use it. You can use it outside. So if you have a TensorFlow project and you create a TensorFlow model, you can use it then in Python or in your own code. So that can also be a really cost-effective way then of using a model that you create in BigQuery in your own project outside. So there's a lot of applications for the models that you're creating here. So okay, we have our fields created. Let's run this. Let's run this query and get an idea of what this query looks like before we create the model. And also we want to make sure, I had this in telco, but we want to make sure this is telco train. Okay, so this looks good. So let's go ahead and create the model. And we have a really small data set, and there's only 5,000 records in the training set, so this isn't going to take more than a few seconds to run. And the model is going to show up inside the data set here. Okay, so now it is the fun time where we're actually going to make some predictions on our test set and see what we actually get back. So the thing we want to look for, we're going to switch from our training set to our test set. We're going to look at that churn. The churn feature, and we want to get some actual probabilities to see one, if the customers are going to churn, and we want to get some actual probabilities to see. So just not just if they will, but how sure BigQuery ML is that they're going to churn or not. So a couple of quick changes to our last query. We're going to switch from ML evaluate to ML predict. And then we're going to switch from train to test. So let's run that and drag that up. So here is what changed. So predicted label, and remember 0 is not churn, and then 1 is churn. So this is how we want to read this. So label is what they actually did, and then predicted label is what BigQuery ML thought it was going to do, and then predicted, this is the probability. So for instance, this one, it thought it was going to be a 0, it was a 0, and then it was 95% sure that it was going to be a 0. And same thing for this one. So this one thought it was going to be a 0, it was a 0, and it was 81% sure. One thing that's kind of interesting, let's see if we can find the ones where it was incorrect and see what the probabilities are. So if we type in where predicted label not equals label. I wonder if there's going to be some that are closer to 50-50, or if it was really sure about them and wrong. Looks like actually it was really sure about them and wrong. Here's one that was 54-45, 64-35, 61-38, 72-27. Yeah, some of these it was actually really on the fence about. So that's an initial look at BigQuery ML. I hope that was helpful. It's something that we're going to be definitely talking about in future videos. Thank you for watching. I know this was a little bit of a long video, but I hope this was helpful. If you're interested, please subscribe for more on BigQuery, Google Analytics, and Google Tag Manager.